Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. Today's question comes in from one of our listeners.
Hello, Naked Scientists and James. It's Laurie in France here, and I've got a little question about electricity, really, power generation. If we can put small nuclear reactors on submarines and Mars rovers, why can't those small nuclear reactors be used along with sustainables to power our towns and cities? Thank you.
Thanks, Laurie. Nuclear reactors split the nuclei of heavier atoms from the periodic table, most commonly uranium, in what's known as a fission reaction. The energy released from this process can be used to generate electricity for national grids. Unlike coal, oil or gas stations, nuclear power plants do not produce CO2 during their operation, and they're expected to play an increasingly vital role in the clean energy transition. You're right that nuclear reactions are also being harnessed to generate the energy needed on board long missions to the depths of the ocean and the surface of Mars. So, is nuclear power the fix-all to every energy challenge? Here's Simon Taylor, Research Associate at the Energy Policy Group at the University of Cambridge.
It's possible to create a workable nuclear reaction that allows you to generate electricity on a variety of scales, including very small. The idea of putting them on a Mars rover, or indeed on submarines and some ships, is because they can provide energy over a very long period of time in a very reliable way, in a way that you couldn't achieve with fossil fuels in a very concentrated form. If you're thinking about a Mars rover or even on a nuclear submarine, cost is not the main consideration. But if we're thinking about providing electricity for homes and businesses, cost is pretty important.
Mars rovers use something called radioisotope power. Radioactive plutonium gives off heat as it decays, spinning a generator designed to produce 110 watts of power, about the same used by a light bulb. This powers the rover's instruments and keeps it warm during the freezing nights and winters on Mars, and as the isotope of plutonium being used has a half-life of 88 years, it will provide energy for as long as the mission needs. But meanwhile, if we're talking about nuclear reactors to power our towns and cities, that's very different. We need them to be affordable, to work at scale, and produce much more energy. But recently, there has been interest in using smaller reactors to be able to do this.
The history of not just nuclear power stations, but also coal and gas, is that bigger has generally been better. There are quite good reasons for believing that there are economies of scale. There are really two parts to this. First, there are a lot of fixed costs to doing any project to build a new power station, things like siting and permissions and so on. Those are the same pretty much whether you're asking for a 10 megawatt power station or 1,000 megawatts. Secondly, a lot of the equipment that goes into nuclear power stations is the same as for other power stations, other thermal power stations. And generally speaking, it doesn't cost 3 times as much to build a reactor 3 times as big. What's new now is the idea of small modular reactors, which claim to be able to be cheaper ultimately than big nuclear reactors. Big nuclear reactors, at least in Europe and the US, have proven in recent years to be extremely expensive to build. It's the construction cost that's been the problem. And small modular reactors hope to be able to overcome this by being made from more modular components. That's to say, essentially a smaller number of relatively standardized components, which can be produced at cheaper cost because you're mass producing them, maybe not mass producing in the sense of a car, but producing far more units, and also which allow you to benefit from the quality control that you get in a factory as opposed to building out on location.
So, Laurie, while the technology on board Mars rovers and nuclear submarines are very cool applications of nuclear physics, this model isn't right for powering our towns and cities when it comes to the economics. But smaller nuclear reactors are being explored, and at least in principle, small modular reactors may allow us to have affordable, cheaper nuclear power for the grid than traditional nuclear power stations. There are a number of small reactors in operation, But to test the theory properly on their claimed economies of scale, we need to see a few more be constructed and the effects of that mass production. Thanks so much for your question, and to Simon Taylor from the University of Cambridge for help with the answer. Next time, we're answering this question.
I'm Jeff Frid in Toronto, Canada. My question is this: are there any ways now, or anticipated, in which AI will cause or encourage actual reductions in greenhouse gas emissions and or lessening of environmental degradation? Or is AI all negative on the environmental front? Thank you.
If you have any thoughts on that or any of our other questions, why not log on to our forum and join in the discussion over on nakedscientists.com/forum. Be sure to drop us a line also if you have a question of your own. The address is chris@thenakedscientists.com. Until next time, from me, James Titko, thanks for listening and goodbye.
Question of the Week is part of the Naked Scientists podcast. Look us up online at nakedscientists.com.